Students, welcome to our video lecture. In the last lecture, students, we have completed relation. Now students, we are going for the definition of function, and students, function is one of the most important concept of pure mathematics. Let us deal this with an example. Now say students, I have any two non-empty sets A and B. Say set A is 1, 2, 3 and set B is say A, comma B. So all of you know that A cross B will be set of ordered pairs 1A, 1B, 2A, 2B, and then 3A and 3. Now I write F as a subset of A cross B, and F is written as say 1A, 2A and 3B. Students, all of you concentrate. I have any two non-empty sets, say A and B. Based on A and B, all of you know how to define Cartesian product. So I have taken A cross B, which will have 6 ordered pairs. Now F subset of A cross B, so definitely F is a relation. F subset A cross B, so definitely F is a relation. Now students, I am defining function. All of you pay attention. Let A and B be any two non-empty set. Let A and B be any two non-empty set. Of course, students, A not equal to null set, B not equal to null set. A relation F such that for every element of a relation F such that for every element of A, we have a unique image in the set B. Means 1 is connected with A, 2 is connected with A, and 3 is connected with B. I repeat, a relation F such that for every element of A, we have a unique image in the set B, then such a relation F is defined as a function from set A to set B. So definitely a function is a relation, but every relation is not a function. So the definition goes like this: for any two non-empty sets A and B, a relation F such that for every element of A, we have a unique image in the set B, then such a relation is defined as a function from A to B. So students, I can say F is a function from A to B, where A is domain and B is codomain. A is domain and B is codomain. This is to be understood. Once again, for non-empty sets A and B, a relation F such that for every element of A, we have a unique image in the set B, then such a relation is defined as a function from A to B. So students, if I say ordered pair 1, A belongs to F, then image of 1 under the function F is A. Then 2, A belongs to F, so image of 2 under the function F is A. And 3, B belongs to F, then image of 3 under the function F is B. So this A is called image. This A is also called image, and this B is also called image. So image of 1 under the function f is A. Image of 2 under the function f is also A. Image of 3 under the function f is what? B. Now if f of 1 is equal to A is called image of 1 under the function f, and 1 is called pre-image of A under the function f. So 1 is called pre-image and A is called image. Same way, pre-image of A under the function f is 2 and pre-image of B under the function f is 3. So when I say ordered pair 1 comma A belongs to f, A is the image of 1 under the function f and 1 is pre-image of A under the function f. So the value written on the left hand side becomes pre-image and the value students written on the right hand side becomes image. So every function is a relation, but every relation is not a function. Then students, we have to remember two important things for function. First element of ordered pair cannot be repeated. Check, in these three ordered pairs, the first element cannot be repeated. So whenever we have an ordered pair representation of a function, students, the first element of ordered pair cannot be repeated, whereas second element in the ordered pair can be repeated, students, for any number of times. The second element of the ordered pair can be repeated for any number of times. And in the definition only I told, for every element of A, we have a unique image in the set B. So none of the elements of A can remain unassociated. So remember two important things for function. In the ordered pair representation of a function, the first element of the ordered pairs can never be repeated. Second element can be repeated for n number of times. And as per the definition, no element of domain must remain unassociated. For every element of domain, we should have an image in the set B. There can be few elements of B which may remain unassociated, but none of the elements of A, students, can remain unassociated. Then when we write an ordered pair 1 comma A belongs to F, image of 1 under the function F is A and pre-image of A under the function F is 1. So in simple words, the number written on the left hand side becomes pre-image and the value written on the right hand side becomes image. This we have to remember, students. So if f is a function defined from A to B, A is domain, B is codomain. So this is what, students, we have to remember. Now based on this, students, let us do the first sum of exercise 2.3. students. I am doing the first sum of exercise 2.3. All of you pay attention. Yes, students, we are doing the first sum. Now we are given few ordered pairs, and of course, students, the definition of range also remains same. In the ordered pair representation of a function, the set of second elements in the ordered pair or set of images always becomes range. So definition of range is very similar to the range of, you can say, relation. Now students, exercise 2.3, answer 1, part 1. Check whether the following relations are functions or not. If it is a function, then find its domain and range. So 2, 1, 5, 1, 8, 1, then 11, 1, okay, then 14, 1, and then 17, 1. Okay, this is the first sum. Second sum also I am writing, ordered pairs, 2, 1, 4, 2, 6, 3, 8, 4, then 10, 5, then 12, 6, and then 14, 7. Okay, let me write the third also. Set of ordered pairs, 1, 3, 1, 5, and 2, 5. Okay. I told you every function is a relation, but every relation, students, is not a function. Let us see. Now, three things or two things I told perfect. In ordered pair representation of a function, first element can never be repeated, whereas second element can be repeated n number of times. Let us check. These are the first elements: 2, 5, 8, 11, 14, and 17. Is any of the element repeated? No. Second element I told you can be repeated for n number of times. One is repeated throughout. So no repetition of first element. Yes. Second element can be repeated. So this relation is a function. So this relation is a function, and domain is the set of first elements 2, 5, 8, 11, 14, and 17, and range is the set of second element, which is only 1, so simply set 1. Range of a function or a relation is the set of second elements, or in other words, if I say range is also a set of images, the concept is same, students. Range is the set of images. So the given relation is a function, domain we have written, students, range also we have written. Now students, second relation, check. The first elements are 2, 4, 6, 8, 10, 12, 14. No repetition. Second element can be repeated for any number of times. So this relation is a function. And the domain is 2, 4, 6, 8, 10, 12, and 14. And range is 1, 2, 3, 4, 5, 6, and 7. Range is always set of images or set of second elements in the ordered pair. Okay, students, now this. First element 1, first element 1 repeated. So this relation is not a function. So if it is not a function, no question of writing its domain and range. That's all, students. So this is very easy. In the ordered pair representation of a function, students, the first element can never be repeated. Second element can be repeated for n number of times. Okay, now students, third question I am doing, and then students I am doing fourth question. The third question is, the functional rule is fx is equal to 2x minus y. Find the values of the following. Okay, students, exercise 2.3. the answer, a functional rule is fx is equal to 2x minus 5. Then find the following values: f of 0, f of 7, and f of minus 3. Okay, students, we need to find these three values. Now all of you concentrate. F of 0 means wherever there is x in the function, replace it by 0. I want to find image of 0. So this will be 2 into 0 minus 5, which is 0 minus 5, and that is how much? Minus 5. So if I want to find image of 7, replace this x by 7. So 2 into 7, 14 minus 5. So the answer is 9. Then, f of minus 3, replace x by minus 3. 2 into minus 3 minus 5. Minus 6 minus 5. So the answer is minus 11. Minus 6 minus 5, students. So the answer is minus 11. That's all, students. Now let us do the fourth step. Now, students, sum number 4. The formula to convert, students, the formula to convert Celsius to degree and degree to Celsius, we have this. So T of C is equal to 9C by 5 plus 32. Okay. T of C is equal to 9C by 5 plus 32. Find the value of T of 0, T of 28 and T of minus 10. Okay. The first value is T of 0, second value is T of 28, and the third value is T of minus 10. Okay. And fourth, if T of C is equal to 212, find out C. Okay, students. Now all of you concentrate. T of 0 means replace this C by 0. So 9 into 0 upon 5 plus 32. So this is 0 plus 32. So the answer is how much, students? 32. Then it is T of 28. Okay. 9 into 28 by 5 plus 32. Now, students, to find T of 28, 9 into 28 by 5 plus 32, very easy, students. You can take LCM and simplify. Just I request you to do on your own. Now T of minus 10, 9 into minus 10 upon 5 plus 32, 5 ones are 5, 2s are. So 32 minus 18, so the answer is 14. Then T of C is 212, so 9C by 5 plus 32 is equal to 212. So 9C by 5 is 212 minus 32. So it is 180. So C will be 180 into 5 by 9. 9 ones are 9, 2s. So this is of course 100. So very easy, students. We get the answer. Now, students, we are doing some special type of functions, and this is again, students, a very, very important concept. So I request all of you to pay attention for the concept of type of functions. students, this is going to be very, very important. Different types of functions. First is identity function. Students, the first type of function is identity function. Now, in this function, domain is R, codomain is R, and the functional rule is f of x is equal to x. All of you please concentrate, students. This is again a very important and very interesting topic. Say the first type of function which I am defining is, students, identity function. Domain R, codomain R. Functional rule is f of x is equal to x. It means for every x belonging to R, f of x is x, means image as well as pre-image are same. Image of x under the function f is also x. So if I write x as 1, f of 1 will be 1. If I write x as minus 2, then f of minus 2 will be minus 2. Because our domain is R. If I write f of root 3, then f of root 3 is root. F of 1 is 1. F of minus 2 is minus 2. F of root 3 is root 3. F of 5 by 9 is 5 by 9. So identity function is such a function, students. Identity function is such a function where image of every element of domain is the element itself under the function f, where image of every element of domain under the function f is the same, and the graph of identity function is a line passing through origin. So like this. So this is x and so this is y. 0, 1, 2, 3, minus 1, minus 2. Here 1, 2, 3, minus 1, minus 2, minus 3. Negative side of x axis and y axis. F of 1 is 1, f of 0 is 0. And f of minus 2 is minus 2, f of minus 1 is minus 1. So, graph of identity function will always be a line passing through origin. So, as soon as students we define a function, say identity function, what is domain? R. What is codomain? R. Second, functional rule. Functional rule is f of x is equal to x. Means for every element of domain which is x, its image under the function f is x itself. Then the third thing, the graph. The graph of the identity function is the line, students, which is always passing through origin. The graph of identity function is the line which is passing through origin. This much, students, we have to remember. And of course its range will be also R, because its domain is R, so its range will be also R, because image of every element x under the function f is x itself. So if x is a real domain, and range will also be same. So range of identity function will be also R. So as soon as you study a type of function, figure out its domain, codomain, range, functional rule and graph. This much is very, very important. Okay, the second function is constant function, students. The second type of function is a constant function. Students, the second type of function which we are studying is a constant function. F is a function defined from R to N. Students, the functional rule will be f of x is equal to k, where k is a real constant. The functional rule will be f of x is equal to k, where k is a real constant. So I told you, whenever students we study a type of function, the first thing is to locate its domain and codomain. Domain and codomain. Alright. Functional rule is f of x is equal to k. It means for every x belonging to domain. For every x belonging to domain R, f of x will be always k. So range of this function is simpleton set k. Say for example, if I take x as -1, then also the image is k because there is no x on the right. I take f of 0, then also it is k. I take f of 2, then also it is k. I take f of root 3, then also it is k. So every time image is the same. So a function where you can say images are same for every element, such a function is called constant function, or in another words, a function whose range is a singleton set, students. Such a function is called constant function. So if I am going to plot the graph of this function, then students check. Say this is y-axis, this is x-axis, this is 1, 2, 3. Say this is -1, -2, -3. And suppose I take this functional rule as f of x is equal to say 3. This is an example. Say this is 1, this is 2, and this is 3. So f of -1 will be also 3. All this will become 3. So here, f of 0 is also 3. F of 2 is also 3. F of root 3 is 1.73. That is also 3. So its graph will be a horizontal line parallel to x-axis. This will be y is equal to 3. So students, as I told you, whenever we define a function, first thing is to understand what are domain and codomain. So domain and codomain are range will be simpleton set k, where k belongs to R. Here as per our example, it is simpleton set 3. Then graph of this function is a horizontal line which I have shown, and a horizontal line is always parallel to x-axis. So graph of a constant function is a horizontal line, students, which is parallel to which axis? X-axis. Now students, we go for polynomial function. Next is students, polynomial function. Now I know some of you are allergic to the word, I mean to say to the word polynomial, but it is going to be very, very easy, students. The third type of function is polynomial function. Now students, I am not aware of whether you are thorough with polynomial in your standard 9th and 10th. But you have to understand, and it is very, very simple. Say the polynomial function f has domain R and codomain R, and the functional rule is like this: a0 is constant plus a1x plus a2x square up to an x raised to n, where powers of variable x are always integers, where powers of variable x are always positive integers, to be very perfect. Power cannot be negative also, It can be 0 here because I can write a0 as a0 x raised to 0. So the power of variable is 0, otherwise positive integers. Such a function f is called a polynomial function. Say for example, I write fx is equal to x cubed minus x squared plus 7x plus 2. This is a polynomial function because powers are positive integers. But if I write fx is equal to x raised to 1 by 2 minus x cubed plus x plus 11, this is not a polynomial function because 1 by 2 is not an integer. So in a polynomial, the powers of variable x should be positive integers, so minimum power in the constant term is 0. Such a function, students, is called polynomial function. So one has to be very careful, students, in understanding the polynomial function. And graph of a quadratic polynomial. Suppose I have a polynomial function like this. Y is equal to fx is equal to x squared plus x plus 2. Graph of a quadratic polynomial, students, is always a parabola. The graph of a quadratic polynomial, students, is always a parabola. This we have already studied in your standard 10. There is no generalization of the graph of a polynomial function. It depends on the function and especially the maximum power of the variable. So the first thing, what is domain and codomain of polynomial function? R. What is the functional rule? Fx is equal to a0 plus a1x plus a2x square up to an x raised to n. Range of the polynomial function, students, all of you pay attention. Even I can say that range of the polynomial function also depends on the function. We don't have any general criteria. And for graph of polynomial function also we depend on the maximum power of x in the variable. So I cannot predetermine the range and graph of a polynomial function. So this much, students, you have to perfectly remember. Remaining concepts, students, we will consider in the next lecture. Study this lecture very well. Write all the definitions and concepts thrice. This is the most important concept of the chapter. Thank you, students.